So, sir, for our viewers out there, what exactly is structural consultation and how does it contribute to better construction?
Yeah, it's a very good question, useful for the people. Many people really do not know what is structural engineering. They hear about architect, they hear about interiors, but structure is the very important element in any construction. Even if you want to erect a gate, you need a real structural engineer. Otherwise, by God's grace, sometimes it will be good, otherwise it will go bad. So it's always good to have structural consultation. In fact, to be precise, it is not just structural consultation, it is civil and structural consultation. Because structure means we talk about concrete, we columns, beams, slab, and steel reinforcement in the columns, beams, and slabs, and foundation. In addition to that, we also decide where all columns have to be placed and what is the size of columns, what is the beam size and its placement, slab thickness. All this is decided by structural design, and we call it detailing.
Okay.
That means how to place the reinforcement. That is also decided by structure. In addition to that, civil engineering contributes in terms of excavation, how to excavate, how to support the foundation, what is the formwork, and what is the waterproofing. Nowadays, we are seeing weatherproofing,
Right.
waterproofing. Even paints are advertising as a weatherproofing. But actually, it is the job of a civil engineer who will decide about this. So, combination of civil and structural consultation will make the building safe, durable, stable, and livable.
So, it ensures long-term durability of a building.
Exactly.
Okay. So, does every building need to have structural consultation?
Definitely. Even a smallest, like if you have an arch, entrance arch, kaman in Hyderabad language, it needs a structural engineer design actually. But many people think that, or they do not know, they are ignorant about it. But sometimes you may provide more steel and more structural size than required. Sometimes you may put less, which is more dangerous. So in both the cases, only structural engineer can give the accurate what is required, size and reinforcement required, and make it stable and perform for the life of the structure. So every small building also, like an independent house, ground floor only, also needs a structural engineer. Because I remember in Chennai, my early days of design job, we have done retrofitting of a house, just a ground floor building, which has settled in the soil. Cracks are there in the entire building, and we had to give the foundation strengthening for that and restore the structure. So, like that, it is always good to have a structural consultation for every. In my words, I always say every lakh of rupees spent on concrete and steel, better consult a engineer.
Great, sir. So, as a customer, should this be a factor while purchasing a house? Should a customer actively check for if this project is being consulted by a structural consultant? Will it be better for me? Should
Yeah,
a consumer
that-
look out for that?
That will be a wiser choice of a customer if he verifies who is the structural engineer, whether for that project there is a certificate from a structural engineer. We call it stability certificate. Even this is required by GHMC approving authorities like GHMC, DTCP, or HMDA also. So it is the structural engineer who studies the location of the building and its requirements, foundation requirements, everything they will verify, and they will design, they will plan sizes of the elements and all, and give the drawings, and also verifies during construction whether that construction is done as per the drawing or not, and also the site supervision, when it is there, it is the responsibility of the structural consultant to verify the quality, whether it is being followed or not. And finally, after construction, before fit for occupancy certificate is issued, structural engineer will give a certificate that this building is constructed as per the design. This is very, very essential. We have seen devastation in Gujarat, for example, post earthquake, or devastation in Vizag, post Hudhud wind earthquake, and sometimes we have seen due to fire buildings collapsing. And so all these aspects are considered by structural consultant for any building, whether it is small, big, complicated, or complex. All the buildings require a structural engineer, and they will be healthy
in the long run. So I have this little question about earthquake-proof buildings. As a child, I was very fascinated seeing in the news that some of the buildings can be built, making them earthquake-proof. So what exactly is that process, sir, and how does it actually help? And I'm talking about magnitudes above 6, 7. Will it actually help in the durability of the building?
Definitely, because we have, we call it technically seismic resistant buildings or earthquake proof buildings. Both are same, but we have a code for seismic resistant design. Bureau of Indian Standards has defined every type of building, how we have to consider the seismic loads. And even we have seen during earthquakes, roads failing. In Japan also recently we have seen, though the Japanese follow very meticulously the seismic resistant design. In Japan, they have almost reached a stage where it is like just a vibration, earthquake, and they'll get back to work. So not even interiors will be damaged. Whereas in India, we have seismic resistant code, which will assure the safety of the structure, stability of the structure, if it is designed by structural engineer as per the code. So earthquake-proof design is very, very essential in every part of the country. And particularly important buildings like communication buildings, hospital building, they require more, we have importance factor. Whereas normal residential buildings with normal importance factor also, it is good, but we make it safe. We have seen in Gujarat earthquake, as I mentioned before, many buildings which are not designed for earthquake proof have collapsed. Many people died, but those which are engineered properly, which are planned and designed by structural engineers, they have withstood the earthquake. Though that was the worst earthquake we have seen in India, particularly in urban scenario, where magnitude is one thing and duration we call. 90 seconds duration earthquake was there. Because of that, damage was very extensive. We have seen in Gujarat. So at least after seeing such experience, we should not ignore or take it easy of this earthquake effects on the building. So even a simple ground floor building can kill people. We have seen people dying just carrying marble slab if it is not handled properly. So every aspect of building, whether it is flooring, ceiling, or some we have good lighting fixtures, anything can kill people. So unless we design the building for earthquake resistance and detail it for ductility, it is not safe to live in such buildings. So it's always good to consult a structural engineer for every building, particularly for earthquake also.
Earthquake. So in a country like Japan, where it's a very normal thing, you get up and you experience earthquakes every now and then. If you're talking about a very high magnitude, will making it earthquake proof actually help? Because in the news, I've recently in the news, I've been reading that a lot of structures collapsed once the earthquake hits. So can you completely make it earthquake proof, or to an extent you can safeguard it?
No, to the knowledge that we have. For example, I'll give you, I had the opportunity to chair a session of earthquake resistant design in Singapore where all 5 speakers are from Japan. So I had the opportunity to understand how Japanese handled earthquake resistant design and how Japan is the worst affected region in terms of earthquake. But still, they are the fastest growing economy and they have recovered from even the worst disasters very fast because of their disaster management and also earthquake proof design. There is a famous earthquake called Kobe earthquake in Japan, which happened around 1980. Till then, buildings in Japan were designed for earthquake and they were safely performing. But Kobe earthquake, there was devastation. Then immediately Japanese engineers studied the reason for the failure in spite of, despite the design being done for earthquake resistance. And they found that there is a new phenomenon of vertical acceleration.
Okay.
Normally we design earthquake for horizontal acceleration. After Kobe earthquake, the entire world has realized we have to also consider the vertical acceleration. So in India also now we consider earthquake for vertical acceleration. But Japanese have found that and they have retrofitted all the buildings in Japan to be safe for vertical acceleration also. So after that, most of the time, there are no damages, structural damages. But again, recent earthquake, we have seen some damages. Probably there will be a study on why it caused, because they don't design any building without considering earthquake resistance. But in spite of that, if some damage happened, means they will study what is the nature of that earthquake and we factor in that. Because earthquake is something, it's a nature's fury actually. Very difficult to understand or predict when it will happen and how it will happen. Every earthquake is a lesson, even in our country. We have changed our earthquake code in our country twice after Gujarat earthquake. So like that, even with awareness, we are able to reduce the damage. If there is no awareness, we can't prevent the damage.
So being based in Hyderabad, should we be worried?
No. Fortunately, Hyderabad is on Deccan Plateau and it's not earthquake risky zone as such. Okay. But still, we are seeing changes in the zone patterns. As I said, it's not predictable. We cannot be complacent. We have to consider the design and provide, but need not be worried.
That's peaceful to listen to.
Most worrisome in our country now is Delhi.
Delhi.
Yeah.
We keep hearing news about
high risk zone 4. And so far we are seeing all around Delhi, Bihar it was there, Madhya Pradesh, Gujarat we have seen, Pakistan. All around earthquakes are happening. So we don't know when it will affect Delhi capital, but pray God, nothing should happen.
So speaking about earthquakes, Burj Khalifa all over the world is admired for its structural engineering excellence. So being a structural engineer, why is it admired all over the world, and can you break it down for us?
Yeah, it's really most favorite thing for me. I consider the structural engineer of Burj Khalifa as my god.
Oh, wow.
In fact, I met him 4 times. I had the opportunity to attend technical presentations on Burj Khalifa. I visited Burj Khalifa construction thrice. And I had the opportunity to understand what it is, actually. Particularly with reference to earthquake, they considered to build the tallest tower in the world in Dubai because Dubai is least earthquake prone. So there is no history of earthquakes happening in that Middle East region, number 1. And number 2 is wind also. Dubai has the least wind. Compared to our India, we have 55 meters per second or 200 kilometers per hour wind speeds. Whereas in Dubai, it is 33 meters per second. So 120 kilometers per hour. So that is the least possible wind. That is one advantage Dubai has. And the Burj Khalifa is the most appealing structure because the developers of Burj Khalifa have conducted a competition for the design. And that design was given by structural engineer William Baker, who works for SOM, who is the partner in SOM. And he has, always there is beauty in simplicity. Like we know the best English is simplest sentence. Similarly, best structural engineering is simplest structural system. So buttressed core, it is called. He has chosen the strongest elements, stiff elements, placed in best possible way.
Foundation.
No, in the structure.
Okay.
Core we call, like where you have elevators, staircase, all that, ducts and all. That is the core of the building. And you have 3 limbs for Burj Khalifa. All the 3 limbs act as buttress to the core. So the resistance of the wind, to put in the words of the designer, in fact, when he visited Bangalore for a conference, one of the Times of India reporter asked, how do you design such a tall building? Because wind is the highest in such tall building. Then he answered, I confuse the wind. Really, he converted the highly technical word into a simple language. Like boxing, when you face the boxer, when he tries to hit, we escape. We confuse the opponent. Same way, structure also, in wind, we have different mechanisms, methods of reducing the effect of wind on structure. So he followed that in the structure. That also, always when you design naturally, it will be beautiful. Like healthiest person looks smartest, what we see.
Yeah.
You can always make, similarly, healthiest structure looks most aesthetic actually. That is, you don't find any extra concrete, no extra steel, and no fascinating or jingoistic elements in that building. So that structure looks so slim, sleek, and aesthetic. So you don't see any extra things coming out of the building, and it is the stronger base, and as you go up, it is the slim. That is structurally efficient and structurally meaningful for reducing the effect of wind on the structure. That's why it looks so aesthetic and beautiful.